Okay, let's see what we get on inrush now. 21.5. Okay, now let's see what we get for running amps. About 9. Power factor is 0.85. We're pulling 900 watts. So we're pulling more watts, but we've got a more efficient motor going on here.
This video is brought to you in part by TruTech Tools. Quality tools, essential support.
All right, guys, don't do residential very often because I've done it for way too long. And so today we're going to do one, if I can get the video on it. Customer's got a furnace, thinks the control board's all burned up. So we're going to go in here and see what we got going on. I'm sure I'll have to hear what's going on first, but then we'll see where we can start at. Let's get started. All right, so it's kind of an older one here. And I've already checked through the heat exchanger here and made sure the heat exchanger's fine. I'm able to look down through here, see the back side of the heat exchanger, see able to go up into the evaporator. Everything looks fine there. His problem is down here on this control board. You can see that it burned up right there. So it looks like a newer motor. So I'm kind of curious, is there a problem with the motor? Was it not starting? Is that what caused it to happen? Or is it just that this thing is at least 2001, serial number is 01, and it looks like an Armstrong. Could be a Goodman, it's hard to tell. Actually, it is a Goodman. Oh well, really super nice house though. Oh, that's really nice. It's really fancy. Wow. All right, so I already went and picked up the controller. It's a ICM control, it's universal. You can see the old one here. It totally got burned up. The starting amp draw, which was one of the things I checked on the motor, was pulling like 23 amps, whether it be in rush or just watching the motor itself. And so we've got the new board in there. This is pretty cut and dry. That's why I didn't really record a lot of it. And this is why a lot of times I don't really do a lot of residential calls, videos, because there's really not a lot. Biggest thing, check your igniter. Make sure the resistance is lower than usually 92 to 95 ohms. If it's an old-fashioned, silicone igniter, I forget exactly what they call them. It's been so darn long. As far as the in-shop burners, I checked all of those and made sure the heat exchanger's not cracked. I went through there. You can run your camera through there and look. I was able to see all the top section. Then I pulled out my limit here and I checked up on the top all along the main side. Usually, if you're going to get a crack, a lot of times it's going to be in that first section of the primary heat exchanger, which means the first section that it burns into. Usually you'll possibly get direct impingement on the metal, and that's always a bad thing, and that'll end up causing the heat exchanger to crack. Another thing to check out down here is collector boxes, which you can see this one's got a crack on it. Homeowner pretty much has been doing a lot of, I don't know, let's just say he's got another furnace sitting on standby. If this one goes bad, he can just swap it out. As long as this here is not leaking, which it doesn't appear that it is, this whole furnace, I kind of already recommended he just replace it. But as long as it's operating safely, I ain't worried about it. This is going to be in a negative pressure, and once it's not, the pressure switch is going to let up. Doesn't really make it right, but we could always put a little piece of silicone or something across that. But this is all going to be in a negative pressure. Pulling it out. We're going to check condensate trap, blow that out, clean it out, whatever, and rough flush it, and then get this board changed. What I ended up doing is checking the capacitor. It was just a little on the lower side. I tried checking the data plate on the motor itself. Couldn't see whether it was a 5. The motor looked like it was replaced within the last couple years. I was looking through history. It looks like we might have replaced it at one time. The motor itself, usually you would think it's going to be a 5, but I brought a 7.5 capacitor down here too. I'm going to try the 5, I'm going to try the 7, see if my amperage is higher or lower with one or the other. Some of these universal motors can be used with a 5, a 7.5, 10, even a 15 microfarad capacitor. And, there's always a chance that it's the wrong one. Should lower starts, should lower run amps. So we're going to try that and see what we get. As far as wiring, it was like for like, nothing major there. It's an ICM board, made in America. UL approved, good American company. Most of their boards are fairly decent. I think I only had problems with one on a ream furnace once. but otherwise they're pretty good boards. No real complaints with them at all. So what I wanted to do now is we'll go ahead and throw a 5 in there. What I did when I first got here to make sure the unit didn't have other problems before I left to go get parts, and this here is ranky dank. You'd have to understand the customer. I can't give away information, but basically this is not uncommon. You know, that's likely that higher amperage on startup is most likely the motor either has got a problem going on. He says he's selling the house. He doesn't really seem to mind too much about that. So you know the story. We're just, all we can do is advise, note it on paperwork, and move on. Honestly, I mean, my feeling is just replace it and move on. But that ain't always somebody's motive or options or whatever you want to call it, and it's not my job to make them want to do it. Let's try the 5. What I did originally, that's what I was going to get at. What I do originally, I'll usually take the blower motor from high speed and I'll unhook it and hook it right where the transformer was plugged in at. That way it eliminates the board and you can see if the blower motor starts and runs. That way you're not hooking it up to a brand new control board, possibly damaging the control board if there is a dead short or something like that. So that is a trick that you can do to prevent blowing up your control board. Now this is high voltage. You want to be careful working in this area. You want to make sure the power is completely off. You want to check it with a meter, an actual electrical meter to neutral and then to ground. Make sure there's no power. Not my problem if you shock yourself, kill yourself, or any of that stuff. I'm always leery about showing electrical because there's a lot of people out there that think they know what they're doing, and then everybody's wanting to make $1 on somebody trying to sue them for their ignorance. Enough said on that, but let's go ahead and try the 5, and I'm going to compare it to the high speed that we had before and see what we get here. So literally what I did was unhooked the wire from the transformer, which was down here, unhook the high speed to there. I want to check it and compare it to what I had originally. I just clamped the whole thing and because it's only powering the motor, and see what we got. Okay, they got a switch back here. It looks about half installed. Yeah, you can see how things are. This is how the business I worked in was. So it's one of the many reasons why I don't mind not doing this anymore. That, and it's just not that exciting. I mean, we found a board that's bad. Yippee. So let's go ahead and see what we got here on start amps. There's our meter. Let's see what our start amps here are. We can do inrush, whatever. Yeah, we'll do inrush. 21 amps. It's already better than what it was. Stop the blower. We don't want it running. We want to do it complete dead stop. Here it is. Yeah, 21. So we've already gotten better. And it's starting up quicker. Let's, for giggles, try the 7.5 here. All right, we get the 7.5 on there. Let's try it now and see what we get. Let's go ahead and do inrush again so it's comparable. 21.5, pretty much the exact same thing, I think. Let's go back here. Let's see what our run amps are. So we're looking at 8.25. Okay, let's swap that capacitor back to a 5. Just remember 8.25. Okay, we're back to the 5. Let's do inrush again. 21.6, it's 0.1 amps difference. Okay, let's go ahead and do this and see what it is on the run. It was 8.25 before. 8.25 versus 8.65. Now granted, we have the blower door off, so when I put the blower door on, that's going to go down. Power factor correction is what they're trying to do a lot of times here, so it does do power factor. Look at that. Okay, good. Well, we can check power factor here. In order to do power factor, we got to get neutral and hot lead here. You got to get it on the right way. It's got to point towards power, which let's point towards power there. You can see on the meter, it's got an arrow. I'm gonna point towards the power source. Make sure you get your meter leads in the right spot. You want as close to 1 as possible. We had the clamp on the actual motor lead, which obviously power is coming back to the motor, so that's why the arrow was backwards. So I hooked onto the power going from the switch down. Now when we go to neutral, to hot lead, and go to the motor lead, now look at what we get. And now we watch it. Got 708 watts, 0.74 power factor. It kind of sucks, but let's do it with the other capacitor, what I assume is probably the right one, so 0.74. All right, so now we've got the 5. Let's do what we got here. Watts lower, but the power factor sucks. It's 0.68. I'm kind of curious what happens if we go to a 10. Let's see what a 10 is. Now we have us a 10 there. Let's see how this one does. Put our meters back where we had it before, meter leads. See what our power factor is now. 0.78. But your wattage is starting to go up a little bit. Yep. You have a better power factor, but your wattage is higher. But are we getting more work out of it? Because it's actually spitting faster. Let's see what we've got here on amp draw. 0.85. Basically, it could be increasing your horsepower. Let's see what our inrush is. See if I can take my finger off. There we go. Let's see what our inrush is. 21.1. It's actually lower. What happens if we go to a 15? I have a feeling this motor, if I could have seen what the motor was rated for, I wouldn't have to be doing this, but I'm trying to lower his starting amps and his running watts so that we don't have to burn up a control board again. We've already lowered it 2 or 3 amps on startup. We got a 12.5 here. The thing is, these motors are universal. I can tell it's a universal motor. They usually allow you to go from like a 1/6 horse up to a 3/4 horse, and it all depends on the capacitor you're using. You got to remember what power factor is. Your sine wave is what you see going on there. It's your AC, that's your actual voltage. Then you have your current behind it. You want them hooked together for a perfect power factor of 1. That's what a resistive load is. An inductive load will cause it to lag. They get out of sync. It's basically something they call the beer factor, and the wattage is lost, or the amperage. You have amperage loss. You're getting charged for it, but you're not really getting the true power. True power, apparent power, and I think those are it. So I'm doing this out of memory, guys. I'm not like freaking got this crap memorized, but either way, let's see what we got now. All right, right here's the motor that I was assuming it probably was. You can see it does 3/4 horse through 1/5 horse. And that one there actually uses a 20 microfarad capacitor. So to say the least, that one there is 8 amps when it's running. But yeah, that's the reason why we did what we did. And we use that motor quite often. Okay, let's see what we get on inrush now. 21.5. Okay, now let's see what we get for running amps. About 9. Power factor is 0.85. We're pulling 900 watts. So pulling more watts, but we've got a more efficient motor going on here. Now, granted, that's cooling speed. I like it better where it's at, honestly. Power factor is good. 0.85 is very similar to what I see usually after it's corrected real close. I'm going with that. Yeah, it's more amperage, but our start amps was a lot better. Our wattage was different. Let's compare it to a 5, which is what we had originally in there. So one more time, because I don't remember. 0.85, 937. Compared to, you gotta be careful, this back EMF on this, which means the motor's generating voltage, could shock your crap. This is with the 5. 700 watts, 0.67 power factor. Yeah, I like my power factor, and even though it's got more watts, I think we're getting more actual power out of it. Probably could actually go to a lower fan speed, but for right now, let's go ahead and correct this back to the way it should be. Let's go to our startup amps, and then we'll check our amperage, whichever you want to call it. 20.9, 20.6. That was with the 5 microfarad. Here's the 12.5. We had 20.6. 20.6. Inrush is the same. Power factor's better, so you're getting actual more efficiency out of it. Yeah, I'm going to go with the bigger capacitor, getting a little more power out of it, which is generally, like I said, how these motors are rated. We probably could go to a lower speed. Okay, we got the capacitor wire tied in there, which this was an oval. It fit in there originally, and that's what they had a round originally. There's no place for it to fit in there. Got it wire tied into place. It's not going anywhere. Let's clean that flame sensor real quick. Something I always do, whether they need it or not. Just yank it out, clean it up. That's why I'm on a nuisance call, especially on these older units like this. They always had flame sense issues. So let's go ahead and get that cleaned. Okay, you can see it's got some corrosion on it. The actual metal is a little bit ate up. Let's go ahead and clean that with my stainless steel wire brush. It doesn't hurt my fingers. It's not gonna hurt the stainless steel or the metal that they make it out of. Okay, we got that. Let's go and get this back up in here and let's get this thing. I went ahead and used my needle nose on these here. Usually linesmans work really good. Unhook both clamps. We're just gonna blow through it because this is all glued together and I'm not gonna break the trap to try to clean it out. Best way is usually to flush it with water. Okay, when you're doing that, make sure you don't blow the water onto your meter. It's not good on it. There we go. Tell you, these crescents they gave me these to try them out and I've been really happy with them. Cheap and they work. Let's go ahead and run it and see what happens. All right, very first thing, draft motor comes on. Next thing should be the pressure switch makes. After the pressure switch, igniter should be energized. Once it's hot, it should energize the gas valve. Then the gas valve lets the gas through. It should ignite. Igniter shuts off. Flame sensor should pick up the rectification through the carbon of the flame. And then the unit should start to get hot. And then the timer for the fan starts. The next thing you know, the thing gets hot and then you're good to go. So that's the sequence of operation. There goes the burners. Igniter should cut out. There you go. Flame rectification should be going on right now. We could check that. Which the 77-3, this thing does everything. I like the clamp. And it does up to 600 amps and it does Cat 3 for 1,000 volts, Cat 4 for 600 volts. So for the industrial stuff, it kind of comes in handy. And it's been pretty darn accurate. I like my fluke though too. This has got a lot of bang for the buck. Field piece is okay, but I've had some issues with some of their different meters. I know that one's 680 or whatever is really super popular. And I've got a couple field piece stuff, but Testo's been really good to me over the years with TrueTech tools, and as usual, you can get yourself a good discount with Survival at checkout. You can use the discount code Survival at checkout to save yourself some money and go from there. But everything's looking really good. The blower just came on. You can check our amp draw if there was an actual regular THHN ran, but they didn't do that. They ran Romex all the way down there. Let's go ahead and check temperature rise. So we got one probe down there. And we got the other one up here, and I got it angled into the duct. We don't want to get radiant heat off of the coil and the heat exchanger. Even though the coil's there, it can block some of the radiant heat, but I still don't trust it. I like to be off by a foot or two. And let's go ahead and check that and see what we got. We're running a little on the warmer side of things here, but man, I hate changing that. So we moved it up to there. It's not helping a whole lot. We could increase the fan speed, but I don't want a lot of noise. And check gas pressure. Okay, we're restarting it. We got the gas pressure test here. Probes are up there. We'll check things both at the same time, see what we got going on. I lowered it a little bit, but I want to check, see where we're at. Light off a little bit smoother than it did. Gas pressure here. The temperature rise on this is rated for 40 to 70. So we were a little bit high. It's usually about as low as you can go. Okay, unless you're blind, I don't see anywhere in there a minimum. It's not as high-tech as what Carrier is about giving you all the different stuff. You can see 3.5, you see 10 for LP, but you don't see nothing for minimum. As long as your coils are clean, which, like I said, I looked up through there. Let's see where we're at now. Okay, we're on 65, we're right at the very top of it. All right, so we're doing pretty good there. So that's why I like the Testo probes. They all fit in the box in my bag. So make sure you check all those things. This is all elementary stuff, guys. Stuff you should have learned in school. But just things that you want to do on your routine checks is, checking temperature drop or temperature rise, whichever one you're doing, cooling or heating. Just common sense. If it's too high, too low, it's an airflow issue. Are all the registers open? Are coils restricted? Do we have blowers that are clean? Is the fan speeds working right? Is the blower motor working right? There's several different things, but those are just some of the most common. Lights off normal. We're good to go. We could check microamps, but you know what? We've been here for a little while. It's running. It's not dropping out. We're not seeing no issues. So I'm going to probably just wrap this thing up. But yeah, we did more than what most people do. And he's using garbage filters, so those aren't going to get too restricted anytime soon. But yeah, there you go. That's how I run a service call when I do residential. Just making sure everything's covered. That way you don't have to go back for something crazy that you should have caught while you were there. Take your time, do it right. Get some silicone on that right there, some red silicone. All right, so went over top of that with the red silicone. It's not the way I like to do things, but like I said, I know how this guy wants to do stuff, so we're gonna do it the way he wants it. It's not hurting anything. It's not obviously the way I'd want it, but it's not hurting anything. It's not unsafe. It's, you know, obviously not ideal, but that's the way we're doing it. It has not tripped the limit the whole time it's been running, so I'm satisfied. All you can do is advise and make sure you note it on your paperwork, everything that you've seen. That way, if there's any issues, it's not coming back on you. Obviously, within reason, you don't want to do anything that's dangerous. Just because you note it, don't make it okay. But yeah, just note anything you've seen that ain't quite right, and go from there. All back together. All right.